Okay, I'm not going to start, but I'm just switching on Hangouts so I don't forget again. You don't want that. Good. Sad, lonely class. It's only the 7, 8, 9 of us. 2, 4, 6, 8, 10, 12, 14. What's the minimum number of students before I have to teach? You're just saying that. No, say like 10%. Okay, we wait a while. I'm hoping everyone is just late because of construction and that they've not decided to all quit the class. I'm not going to try not to be a complete bastard and start without them. So we just have to be patient for a while. I'm sure they'll come. Let's see if we can find the exact time. Because none of my watches ever give the right time. Okay, well, there's still a whole minute left. Special trick here. Let's see. Oh, there we go. Excellent. Oh, why has okay, right. So I'm going to start slowly. I don't mind if you come late. Well, I do mind if you all come late. Kind of set back my time. I'll go so slow in any case. But once again, it's not important if you learn only one thing in this whole course. It's much more important to me that you know one thing than we briefly do lots of things badly. So one thing is enough. If you only know one thing, it's fine. Don't leave. Oh, that's sad. That's not fine. So firstly, oh, there we go. Firstly, I'm speaking English. This is English Week. As I said, and I apologized on Friday for last week's Wednesday YouTube video. Not on the web because I neglected to press the record button. I'm so sorry. I've never done it before. The only other times I've missed videos is because of a network failure. So hopefully it's not turning into a habit. I wonder if there's some psychological effect where people who come in actually pay more attention. And once you sit down, you just fall asleep immediately. If so, this is the ideal opportunity to remind you that there's a test on Thursday in these rooms, A406, A305. It's not in this room. It's not here. Don't come here. It's in the main building. The is after me in general engineering. Please go to 406 and 305. Today, I'll put up on the web who knows where, but it doesn't really matter. There'll be signs on the door. So you have to remember those two rooms. Yeah, sure. I'll get there now. Okay, 5 minutes. Okay. I updated this. This is not an accurate reflection of what's on the web. So data representation shouldn't be there. It takes maybe like a minute or two to propagate. In fact, maybe like an hour to propagate. There are past tests and sample questions, and yeah, pretty good. Right. The only thing that's on the test that we haven't talked about is today's topic, arrays. So today we'll discuss arrays. This is English week. I speak English. The cards videos from last week is up, but only 2 out of 3, and the subtitles are coming. I am physically working on them because one of you offered to translate them for me, and I'm just checking them and syncing them. Right here. So we have to talk about arrays. But before I do that, yeah, I said it's English. Okay, we have to talk about arrays. Let's just double check YouTube. Okay, that looks good. So, what are arrays all about? I have to be really careful because I can't get excited about every single topic we do. But arrays are fascinating stuff. When I was, wow, how old was I? I think I like 11 or 10 years old. I didn't have a home computer, but a friend had a home computer. And there were these games called adventure games. They're all text. So you got a little description and typing commands like go north or go east or pick up treasure, or stuff like that. You had to physically type it. I should have brought this screenshot. It was really fun to play, but I couldn't figure out how they made the game. Because I don't just want to play the game. I was terrible at games. I want to write the games. That's my whole course. I'm not interested in nice programs. I want to make them myself. When I read a book, I want to write the book. I tell you how many books I haven't finished. And I couldn't figure out how these games work. These adventure games, text adventure games. So the secret to how they actually work inside is arrays. You kind of almost certainly need arrays to write a decent text adventure game. And arrays are used for lots of stuff. I mean, there aren't really sensible programs without arrays, not many things. So arrays is really important and kind of exciting, but a little disappointing because they're not as hard as I perhaps made it sound. Arrays are used to store and manipulate large quantities of data. Such as what? Such as if you have loads of playing cards, 52. It would be insane to try to represent something like playing cards using 52 variables that you call x1, x2, x4, what have you. Or 5,000 undergrads at Princeton. If they want to record those marks, they don't use a little variable for each of them. There is no variable at the university that contains your marks. Store them in an array, a bigger variable, along with everyone else. Million characters in a book. We want to store a book. We can't put a book in an ink. We can't put a book in a double. We can't put a book in a string. I guess we could kind of put a book in a string. But it would be really inconvenient to store a book that way on the computer. What else? Audio sample. Oh, we want to play little audio samples. We will need arrays. We'll need arrays to do that. What else? 4 million nucleotides. So the idea of the Sedgwick and Wayne book, even though I ignored it completely, is to have a kind of scientific approach to computer programming. So that you don't just learn all the hello world and what's your name, how old are you, little programs, but you tackle actual real scientific problems. And the book does do that to some extent. I mean, there's really fascinating stuff in this book. I kind of hate this book. I detest it. I detest it because if I try to make up new examples for a test or an exciting tutorial, I have to fight with this book. These bastards have collected every single exercise on the web and put it into their textbook. So it's just every single exercise. You can't find anything nice. But I'll give them their due. And YouTube, I'm going to switch to the document camera now, and I didn't bring my own, so I can't show YouTube. I'll show YouTube in a second. Just be patient, YouTube. These guys, this is switch automatically, perhaps not, have really tried to make the textbook exciting as well, and to make it scientific. So there's loads of science stuff in the textbook. What is this? Oh, that's just pictures of Darwin, it seems like. Yes, it is Darwin. A mandrill monkey. Oh, look at this kind of stuff. I mean, this is fascinating. Percolation. I don't even know what percolation is, but it sounds like something to do with coffee. That stuff, you can't perhaps see it really nicely. Can you? Maybe I should zoom. Auto adjust. I mean, that stuff must mean something, and it looks fascinating. I can't wait. And this is all scientific stuff. Oh, look here. Oh, so I think percolation is some kind of like a synthetic biology stuff, something to do with cells and stuff. And when you do that, you always have these little parts of the population over time, like this one. It's not showing properly, but there we go. That's beautiful. Focus is perfect. So it is a quite scientific book. What was I saying? I was actually trying to talk. Oh, part of the book is that they do a lot of DNA stuff, like little programs to analyze DNA strings. So you know your DNA consists of 4 letters, A, C, T, and G. They're called are they called nucleotides? No, they're not. Or are they? I forget, I've never done biology. So they're definitely amino acids, 4 amino acids that's used to make our DNA, and loads of others as well. And I guess that in the groups of 3, they're called nucleotides. Is that right? Anybody doing biology? The letters are nucleotides. The groups of 3 are what? Codon. Okay, cool, I'll take that. So codons, so what do codons do? What do codons do? I couldn't hear what you said, but you said protein, I know that. So each group of 3, each codon encodes for a certain protein. And these proteins, I mean, RNA stuff in your cells, they rip open the DNA, they read these codons, they make the proteins, and the proteins do the actual work in your body. That's how your body works. Is that correct? Did I sum up the whole of biology? Okay. So nucleotide analysis is fascinating. I mean, this is the kind of stuff we use for forensic analysis of, you know, whose DNA is on the victim, but also loads of other stuff, finding diseases. And we have a guy who's now an external, he used to be here, but he went to San Diego, who did bioinformatics, and this is the kind of stuff he worked on. He analyzed tons of these nucleotides, tons of DNA strings, and then identified which ones are associated with diseases. So this is actual real shit, man. This is like, how do you cure cancer? These papers always started with, these papers always started with people are dying. And it's true, people are dying, and computer science can find cures. And computer science have saved lives. Oh, well. Look how much time I spent. So we want to put nucleotides in the computer, analyze them. We could put them in a string, but it's so clumsy, it's so inconvenient. An array is a perfect place to put nucleotides. All the queries that Google gets, they need to be stored somewhere. They're stored in a humongous array, a literal humongous array. Then things like 50 trillion cells in the body. What if you want to build a simulator that simulates your entire body? Well, we can't do that because 50 trillion is just too big. We don't have computers with big enough memories to store it. And well, we may find such a computer, but then you have to use slow memory, and the whole thing is slow, and it'll take 5 years to simulate 5 seconds of human life. It's not exactly that, but I think it's pretty accurate. I think it's about 1 year for 1 second of your body. 1 year of simulation, like that Monte Carlo gambler problem we did, exactly like that. 1 year of simulation produces 1 second of real time in the human body. And that's because there are so many cells and they all have to be simulated. Maybe. And if we've got particles in a mole, if we want to simulate a real physical substance, so at the cells level, we're not even thinking about how's the cell, what's in a cell, what is the cell made of. We know cells have like, I don't know, what the hell the cells have. A membrane, and they've got that fluidy stuff inside, mitochondria, and cells are actually packed. There's very little room in the cell, they're really full. But we're just simulating these things as real entities if we ever make such a simulator. But of course, we can simulate the particles that they're made of. We can simulate the atoms and all that stuff at one lower level. Then it's just impossible. So what we really want to do is to have variables that can store not one value, but many values at the same time. Instead of storing one int, I want to store 8 integers. Instead of storing one string like Wayne, I want to store 8 strings at once. And Java actually provides a way of doing that. In fact, all model languages do. So before, I had to write this. I had to write, I want 10 doubles. I'll call them A0, A1, A2, A9. And then Java will write 10 boxes, 10 separate boxes. And it will call the first box A0, and the second box A1, and the last box A9. And then I can do things with these boxes. Like I can put values inside each box, make all of them 0. That's hunky-dory. And I can look inside the boxes. I can add box 4 and box 8, A4 and A8, and put their sum in a new box called X. So I could do this before, but there are problems with this. If I have 100 boxes, the code becomes too clumsy, too much. Plus, if I want n boxes, and I don't even know how many boxes I need, how many do I have to declare? Well, I have to think of how many could I possibly ever use. And if that number is 1,000, I have to make cater for the fact that I may have up to 1,000 boxes. It just becomes unmanageable. So arrays is a way to solve that. Arrays, we can tell Java to say, Java, this first line, int n equals 10. It's just regular old, what we know. Make an int variable called n, and put 10 inside the int variable n. Okay, so that's fine. But the second line is new. Double and empty square brackets after the word double, that's a new type. This is an array of doubles. So a whole long array. Not only one, but many. And I'm calling all of them, I'm going to call A. So when I say A to Java, I'm referring to this whole lot of arrays. Doubles. All in a long, well, what is called an array. By the way, whose first language is at home is English? English. Let's find a victim. Don't lie. I saw you. What is array in English? No, array. Yes. No. That's array. An array of colors. What's array? What's the difference between address and address? You might laugh, but this is an important distinction. In English, there are many words where if the stress is on the first syllable, address, it's a noun. My address is, I'm not going to tell you. And if the emphasis is on the second syllable, like address, it's a verb. The state president addressed the nation, or he's about to address the nation. An array is one of those words. It's not important, this is just fun stuff. But an array, which is the one we use most often, is an English noun that exists before computer science. And array is also an English verb, English word, but it's a verb, which is almost never used in computer science, but I know that all the English native speakers, like Melanie, what's her name? Wendy? Ray. Ray. Okay, right. But it wouldn't be impressive if you named the word Ray. Ray, like Ray knows the word array. She probably uses it every single day. What does it mean, Ray? To array something. all the soldiers were arrayed on the field, lined up. Okay, so an array is something that's in a line, and array is the verb. I just say this because it makes it does help to know where words come from. Array is not just some random collection of letters. It's actually a pre-existing word in English. In Afrikaans, this is called a skikken, which is not an Afrikaans word. We never use skikken. Nobody has ever used skikken outside rekenaarwetenskap. But there are other words we do use, like rangskikken. Arrangement of flowers is the rangskikken. I don't know Afrikaans very well. Okay, right. So, skikking in Afrikaans, array in English. What was I saying before Rain interrupted me? Yes, okay, so we're telling Java we want a whole array. So not just one, but a whole list of them, a lineup. And I'm going to call them all A. When I say A, Java's not going to think of one box, it's going to think of this whole line of boxes. But when I say double A, double brackets A, that doesn't create those boxes. It just tells Java that when I say A, I mean that line, which does not yet exist. So I have to make the line. I have to create the line separately. I have to say A equals, and then I say new double, and in square brackets, a size, a number, which is how many doubles have I actually put in that array. So in this case, when I do this first line, I'm telling Java A is going to refer to an array of doubles. And when I do the second line, I say create this array, make a new array of doubles of size n, which is 10. So I'll create 10 boxes in that lineup. And A will point to them. A will be the name for them. So at this moment, I've got my boxes, they're all there. They're called A, but collectively. Each individual box is called A square bracket something. So the name and a number. And the numbers also always start at 0. So the first box will be A square bracket 0. And the second box will be A square brackets 1 up to A square brackets 9. And this for loop starts at 0 and it goes up to n. And I increment I each time. And it's actually putting 0.0 in A0 and then in A1 and then in A2 up to A9. So this little loop here, these 3 lines, is doing exactly what these lines did. Except they're not limited to 10. If I change this program and I make n 100, it'll still work. I don't have to change anything else. I only need to change an n, and then I'll have 100 doubles, or 1,000, however many I want. And I can still do the same thing as I did before. I can access A4, by writing the 4 in square brackets, and I can access 8 by writing the 8 in square brackets. I sum them, and I put them in X. There's a shortcut for declaring and creating, which we almost always use. We almost always write it as one line. This bottom of this so instead, I almost always write make a double array called A, and assign to it create the actual array of doubles, and its size is n. So it's one shot. Yes. Yes. No. Yes, absolutely. All these A contain 0, and it's a stupid program because it's just adding 0 to 0, 0 to 0 to 0, installing 0.0x. It's stupid. I'm so sorry. I should have done something else. I feel bad. But yes, you're absolutely right. X will contain 0.0. What about? Oh, the increment increments I, but I'm not storing I anywhere. I'm just using I to point to the different boxes of the array A. I0, so I'm talking about A0, I becomes 1, I talk about A1, I becomes 2, I talk about A2, and so on. Just before I give you an opportunity to say something, I want to say, when you do this, even when you do that, Java makes all these doubles, 0.0 in any case. So this for loop is a little useless. If I change it, I should have written something and say something else. I'll change it to yes.
Sorry, example.
In this particular example.
If you have left out in A equals 10, just substitute it anywhere.
Yes, I can put anything in here. I can put 10, anything that's an integer. I can put n, I can put 2 times n, in which case I'll have 20 doubles. I can put n minus 1, in which case I'll have 9 doubles. Any expression that's an integer, I can put in here. I think this may show it. No, it doesn't. It's too bad. But this is at least a more sensible example. So if you're not already know about the dot product, the vector dot product, it's an operation on arrays. And in maths, you may have already learned about arrays. They're called matrices in maths. A matrix is an array. And there's an operation on 2 arrays that you can perform called dot product. So the arrays have to be the same size and the same type, kind of. But the operation, I mean, I could do lots of things with these arrays. In fact, let's look at the program. It starts double brackets, so asking Java to make an array of doubles called x, and then something we really haven't seen before. And this is called an initializer. Well, we have seen other kinds of initializers. Here's one for n equals 3. But if I want to initialize an array, I can do that as well. I can put all the values I want in the array, 0.3, 0.6, 0.1, and put it in curly braces. And that'll put those 3 values in x, but it'll also make the array 3 boxes long. So this actually does 2 things at once. It creates a new array that's 3 boxes long, and it puts those values inside those boxes. So x is now an array that contains 0.3, 0.6, 1.01, and y is also an array that contains 0.5, 0.1, 0.4. So if I have 2 arrays, think of it as 6 boxes. 3 for x, 3 for y. And n is 3, cool, and sum is 0. Now, I can do lots of stuff with x and y. So, I mean, I could, for example, add all the corresponding elements. If I add x0 and y0, and x1 and y1, and x2 and y2, yes, I'm basically adding the 2 arrays together. Of course, I need to store that value somewhere, but I could add them. I could subtract them. Multiplication is a little more difficult, because when I multiply by what? Do I multiply 0.5, all the top by 0.5, or by 0.1, or by 0.4, or what do I do with multiplication? And the answer is that when you're not dealing with a single double, but with an array, mathematicians call a vector, there are many ways of multiplying 2 vectors, 2 arrays. One way is called the cross product, and that's really useful in mathematics because I'm not going to go into it, but it's mathematicians like that. But there's also one called the dot product. And the dot product says to multiply x and y, you multiply the corresponding elements, you add them all up. So I'm going to multiply 3 and 5, of 0.3, 0.5, 0.6, 0.1, 0.1, 0.4, and add those 3 values up, and I get a single value. So that the product of 2 vector arrays is now a single double. It's not an array of 3 doubles anymore. That's an odd little thing about product, dot product, but it's just the way life is. And that is actually quite useful. Rightio. So let's see what we do. I create a variable called sum, which will hold my final answer. And then I have a for loop. I starts at 0, goes up to n. I'm going to look at each of the elements in turn. And each element xi, I'm going to multiply by yi. And that product I add to my sum. So the very first time I say sum, which is still 0, plus equals, so it's incremented by x0 times y0. In the next iteration of the for loop, I'm calculating x1 times y1 and adding that into sum. And the last iteration, I multiply x2 y2. Please don't let me make a mistake. I add that to sum. And finally, the final sum. This is just an illustration. It's a little boring. I think there are more exciting things that are coming. So, exciting thing. Hide. Okay, cool. Right. I'm going to get the exciting things. I want to finish it once in my life. This will go. 3. How did we know x and y are 3 long? Well, we can look at them and see. But what if x and y was calculated somewhere else in a different part of the program? Or what if they're not always the same length? What if I read them from the input or the command line? I can't guarantee there will always be 3 numbers. So there is a way in Java to tell from this array name, x, how long it is. And instead of 3, I can write x.length. By adding .length, I always get the length of an array. So this x.length is 3 because it contains 3 elements. It's got 3 elements. And if I asked a.length here, if I talked about a.length, it would have been 10. Because a contains 10 doubles. So I can find the length or the size of an array by just adding .length after its name. It's an integer, it tells me how big the array is. Okay, now the examples. So I've got an array, I don't even know how big it is. I'm showing you it's 10 big, but never mind that. Because this for loop will just fill it with random values. Without even knowing how big it needs to be, it always fills the whole array. So I starts at 0, goes up to the length, the last element, and each element AI, in each of those I store math.value. So each element of the array, each double in the array gets filled with a random value. Fascinating stuff, I mean, really useful. Next example, print the values of an array 1 per line. Oh, easy peasy. So I've got some array A, and I want to print it on the screen. What do I do? For loop up to its length, just print AI each time. And it's printed on the screen. This is useful stuff. You'll be doing this millions of times. It's not that exciting, I guess. Oh, this is something. Oh, test question. Calculate, find the maximum value in an array. So you give me an array of doubles, and you ask me what's the maximum value in this array, or minimum, or whatever. How do I find the maximum? Oh man, it's tricky. There are many ways. One thing is I can just guess it. I could do that. But I may be wrong if I just guess a value. So how do you find the maximum in an array? Something shows you a list of numbers. Rain, since I know your name now, you're going to be today's victim. What's that? Bigger number? Take a bigger number and add it to the list. That's maximum.
Each one is bigger.
Yes. Yeah, that's probably very correct, but it's not an answer I can work with, you see. Well, perhaps. You said go through, so we can work with that. We have to go through the array. I mean, what I wanted you to say is, I'm not going to do your voice now. What I wanted you to say was, well, I put my finger at the top of the list and I just pull it down, and whenever I see a new bigger number, I know that that is the maximum. And I remember it until I find a bigger one, and I go through the whole list. And this is exactly what we do here. I mean, we initialize max to this value, which I'll explain in a second. And then we walk through the array. If I becomes 0, I up to the n. So I'm looking at each element in turn. Every time I increment I, and I ask myself, is AI greater than my current maximum? Maximum is storing my current, the biggest one I've seen so far. So is AI bigger than this maximum? And if it is, if this condition is true, then I put AI in maximum. So maximum is like my memory for the biggest number I've seen so far. And I just walk through the array and I check each one to see if it isn't a new record, if it isn't a new bigger one. So the issue of that is, where do you start? If I just started with max, like the top, double max equals 0.0. If that was my guess for the biggest number in this array, but all the numbers are negative, then none of them would have been bigger than max. Max would have stayed 0.0. So when the for loop is done, max would be 0.0, but that's a lie. Because the biggest number in the array is some negative number, which I don't know. But it's just that none of those negative numbers triggered this update. So what I have to do is I have to start off max, not with 0.0, but with a value that is so small that all possible values are bigger than that. So that whenever I find any value, it'll trigger an update. I start with negative infinity. It's a tiny, tiny number. And then when I get to the first element, that'll definitely trigger it. Because any number is bigger than negative infinity or equal, doesn't matter. So the very first number will trigger this, and then I've got a new estimate, the first number on the list. And then I carry on and on and on. Okay. At least one person has a question which will answer by a single button press. Look at this. Look me in the eyes. Look me in the eyes. Yes. Oh, it's my shirt. Yes.
What will happen if you print the double of negative infinity? What's the number that it will get?
Negative infinity. Don't you know that number? I don't know what it prints. It's a value. It's the smallest value you can store on the computer in a double. But it is some value. Doubles are just approximations. They only use finite space, so there is a smallest number that you can cancel in the double. More questions? One of you, I'll answer with a single button press. Let's start with that. Gentlemen first, that's always our policy. Yes. Oh, okay, right. What do you mean, like this? Okay, we get to that in a second. Same question, but added by. Yes, same question. You. Same question. Oh.
Why is there two maximum?
Oh, that's okay. Because, I mean, let's say there are 2 hundreds in the error. And I get to the first one, and I record this as my new maximum. And when I get to the next 100, it's not bigger than my maximum, but it is also a maximum. It's also 100. But that's fine, because at the end I'll know 100 is the maximum. If that second 100 wasn't 100 but 101, I would have picked it up and that would have been the maximum. This works, and it's actually very cute how it works. So, as Javon, or no, what's your name? Mark. Keanu. That's a fake name. What's your real name? What name did you have in the church? As Keanu suggested, I can guess that the maximum will be A0. I just guess immediately, A0, that'll be the maximum. And then I walk through the array, starting not at 0 now, because I've already guessed that's the maximum. I start at 1. And I check, is 1 bigger than the maximum, than Keanu's? And as soon as I pick up a new maximum, that's my maximum. So this is actually the way I think most programmers find max, which you do not on a daily basis, but you do it a lot. I feel as if my trousers are falling down. I don't know why. Oh man, it's a stupid shirt. I know they're not, but it feels that way. Oh, okay, sorry, my mistake. It's personal. Never mind. Compute the average. Oh, I do this so often with your marks. It's hilarious. Okay, I've got an array. It's full of doubles. I want to calculate the average value, or the average of the values in the double. Now, firstly, that's a very wrong thing to say, because average is not one thing, as Rain will tell us. It's like array. It can be many different kinds of things. Average in mathematics, there are many kinds of averages. There's the mean, there's the median, there's the mode, there's the whatever else there is. There are more than one average. So I should actually be saying mean. When we're sloppy, we use the word average to mean the mean. So let's calculate the mean. I've got an array marks, I don't know how big it is. I use a variable called sum. I should point on this side as well, so these people can also learn a little bit. I have a sum which starts out at 0.0. I walk through my array starting at 0, going up to the last, marks.length. And I just add up all the marks. So I've got the total, the sum, and I simply say the average is equal to the sum, which is a double divided by marks.length, which is an integer, but Java will upgrade this to a double. So we double divided by double, it will give me a double value for average. So, only tricky part in this piece of code is to remember that when you're using a int array, an array of integers, and you sum them into an int sum, at the end you'll get an integer divided by an integer, which will give you an integer again. And you may want 1 decimal point or 2 decimal places of accuracy. So if you're summing up a lot of ints, you must remember that this sum will be an integer, marks.length will be an integer, and that quotient will also be an int. So you have to be careful if you want to be really accurate. Speaking of which, here's an int array, our first new kind of array. For orig, for original, almost done. I want to make a copy of original. So what do? I say, well, make a new array called copy. It's also an array of integers. I create it, and its size is the size of original, orig.length. So copy is exactly as big as original. Also contains integers. Only difference is that original orig has all the original values. Copy has zeros. So I have to walk through copy for int I equals 0 up to, oh, marks at length, damn it. How can I make such a mistake? It shouldn't be marks, it should be orig at length. And each element I copy over into copy. Okay, one last slide, I hope. Yes, this is the last slide. How do you reverse an array? I have an array with lots of values. I'll answer you in a second. I know someone else will. Okay, I've got an array of values, and they're in a certain order. So A0 is the first value, A1 is the second value, A2 is the third value, and let's say it's alphabetical. So I've already somehow sorted this array of string with names in it, so that the alphabetically least name comes first, and so on. Now I want to reverse it. So what do? This is a nice piece of code. I want it in reverse alphabetical order. So let's see what it does. It says I starts at 0, goes up to the last element of names. So each element, I take each element, and then I say 10. Oh, immediately I have a little bell rings in my head. It's lunchtime. No, that's not the bell. This is the bell for, I'm doing a swap. So whenever I see a temp, I always think swap. And in actually, this is exactly what it does. It puts that ith element in temp, and then it takes some other element and puts that in I, and then temp goes into that other element. So this little formula, n minus I minus 1 minus I, is actually the last element that is ith places from the back. N minus 1, these slides are a little screwed up. I'm sorry, that I'll fix them. Let's say n is the length of the array. N minus 1 is the very last element, 0 is the first. So when I subtract 0 from n minus 1, I get n minus 1, which is the last. So the first and the last will be swapped. When n is 1, I is 1, n minus 1 minus I is n minus 1 minus 1, which is n minus 2, the second last element. So the second and the second last will be swapped. And so on. Each element I swap if it's parted from the opposite side. But apart from that, this code has one exciting bug. This code has one exciting bug, which 1 minute to demonstrate. And since we are going to be using cards on Wednesday, I'll show you a card trick that I've just learned in my card magic class. Sorry, YouTube, it's not for you. I'll bring the camera on Wednesday so YouTube can see all my tricks. Let's switch on my card camera. Close up magic, it's all about. Okay, here we go. Okay, let's just pick a few cards. It doesn't really matter what. I'll just do that. Let's do that. Let's get a heart. Okay, right. So here you see the 4 cards, which I'm now going to swap using my algorithm. And I'll put them in order of ascending order. Let's call that alphabetical. And I want them reversed. I want them in reverse order. So I want ace, king, 10, 9. Okay, 5 minutes or almost 1 minute. So I'm going to turn the cards over. This is not a reversing step, okay? I'm just turning the cards over so you can't see my little magic trick. Okay. Now, let's do our algorithm. We start at 0. We've got a for loop that goes all the way to the end. Start at 0 and swap this card with its partner from the opposite side. So these two will be swapped. Next one. This is its partner, swap. Next card, this is its partner, swap. Okay, for loop goes on to the last card. What's the partner? This first one, so swap. Okay, and now they're in reverse order, aren't they? Yes! So if you look quick, if you watch closely, you notice that I actually swapped each card twice. I swapped it once with its partner, and then I swapped its partner with it again. So I should have stopped when I got to the middle of the arrow. When I got to right here, I should have stopped my little card here. Just say this card 0, swap with its partner. Card 1, swap it with its partner. Okay, now I should have been done. So my for loop, which you can still see on the far side, should have gone up to marks of n. Should have been that's of n divided by 2. Because if I did that, the cards would have been in the right order. Okay. If you are a class representative, who is a class representative? 1, 2, 3, 4. Where's number 5? 1, 2. I'm sure I had 5. Never mind. Okay, just come to the front. Okay, I'll see you on Wednesday.